My name is Alexey Shestakov, and as mentioned, I've been working on a design system of JetBrains' websites for the past 5 years. And our team's main product is the JetBrains.com website. It's a marketing site for all JetBrains products. For now, it has more than 1,000 pages and over 17 million visits per month in total. And it's basically the main entry point for JetBrains customers. We also develop a documentation engine for our product's technical documentation, landing pages builder for marketing specialists, custom landing pages for conferences and events, and even landing pages for fonts. And I want to start with a disclaimer. This talk is not a universal recipe for the quick implementation of a good design system. Because when you look back, a roadmap looks like this. But when you are planning something, the roadmap looks more like this. And today I will only talk about the one path we took and some good ideas we found along the way that seem to be working for us. Sometimes in interviews, people know what technology stack they are using on their current project, but they can't answer why or how it was chosen. Today, I will try to answer these questions about our design system and show you our process of choosing technologies and tools. Let's take a look at our current stack. Looks nice, but it raises a lot of questions, actually. Maybe the previous one was simpler. Still unclear. Okay, let's rewind a little further back. Okay, this looks pretty simple. Simple enough, I think. Just take some reusable styles and JS code, put them into one package, and add some documentation. But main question of any project manager is still left unanswered. So we started to working on a project that now became our design system in 2015. And at that time, JetBrains.com looked like this. And then the brand redesign happened. We need to quickly go from this to this. At that time, website's structure looked pretty straightforward. Webpack, jQuery-based components, SCSS, and plain HTML pages. But there was an additional requirement. We needed to reuse the redesigned components on other sites, such as JetBrains blog, for example, which also needed to use the new styles and updated components. So let's go back to the first stack again. Development team just moved some components to an npm-package to reuse them in other repositories. Then we implemented the custom engine for documentation, which looked like this. So basically, we just extracted two bottom layers from JetBrains.com to a separate package. The components were extracted as is, as unprocessed SCSS and untranspiled ES6 JS code. And this means that build configuration was also partially moved to the package. Initially, this looks like a good idea. The build infrastructure encapsulated together with all components in a reusable package. There was a special function in extracted package, which combines build configuration for the library and for the project itself. but over time, it causes a lot of pain. For example, when you need to update the build configuration, you can't just go straight to the newest version of the build infrastructure. Instead, you got all components updates, and you should test that none of their usages is broken. And if there is breaking change in some component, you should migrate UI components while you just wanted to fix something inside build. We also had some issues with SCSS. It took significant time in our build chain and had binary dependencies, which not always works well on different operation systems. And from the code perspective, SCSS encouraged developers to write imperative code with declarative language. And this amount of syntax sugar looks frighteningly unhealthy for me. I think any more would give you teeth some extra cavities. So besides SCSS issues, we suddenly face some product issues inside our cozy, far from production, and for developers only library. Many neighboring projects, which we considered our potential customers, started migrating from jQuery to React, and some new ones started using React from scratch. The library itself also became quite messy because existing components were always pretty much it, but not enough. And I mean that components just cover very similar use cases, but always they need some more small feature which not like can't be combined with previous features. So we ended up with many similar components for similar use cases. And the solution for the first problem was pretty obvious, just use React. But the second one we couldn't solve by just ourselves. So we involved the design team, and together we developed usage guides and cleaned up the components list. And that was the point that I consider as going from a mere components library to a design system, because you can't have design system without designers. With this in mind, we developed technical requirements for the design system. Get rid of shared build configuration and tools, provide CSS API for pure stylistic components like layout grids or cards. It's something similar to what Bootstrap did. And add React components for cases when component need a particular DOM structure and maybe some JS logic. And also, all components should be distributed in separate packages to eliminate these bounded updates. So the goal was to have minimal requirements for the project's built infrastructure from the design system side and for technologies which they're using. And stack was upgraded according to these requirements. We had Learner to manage multiple npm-packages, rewrite components to React, create our own lean CSS syntax using post-CSS plugins. Our custom documentation engine wasn't designed to work with monorepositories. So instead of rewriting it, we took Style Guidist because it has really cool in-browser sandboxes. And we add Babel to transpile JSX code. Bundler for running Babel and post CSS seemed like overkill. So we left bundlers to projects and just wrote our custom script, really small one, which I think 48 lines long, which runs post CSS and Babel in every folder of the Mono repository. After setting up documentation and the build process, we faced question that we didn't think through during the requirements phase. Independent versions are easy to use, but hard to maintain. It's better to follow semantic versioning. It's basically rules for setting versions, which helps package managers to understand, is it safe to upgrade to the next version of the package, or it contains some breaking changes. And to follow this rule, we had to decide what kind of changes were breaking in our projects. Our design system was meant for our marketing sites with complicated layouts and animations. So we defined a breaking change as a change of components into external dimensions. In our cases, most API changes could stay backward compatible for a long time. But the design and appearance should be easy to update, and we wanted to hold back the design team as little as possible. Okay. That was enough for a start, but as design system grew, we faced a new challenge. Components depend on each other through npm, not directly inside repository. So eventually we had multiple versions of the same components on the same project from time to time. This is hard to avoid when you use independent versioning scheme. We didn't want to return to a single package with a painful update scheme. Instead, we decided to fix critical issues that were causing the breaks. It turned out there were two such issues. First, there was a small number of packages for which being singleton within the project was critical. For example, React context providers. We were using React context for setting the theme. And everything worked fine while we were using only one package within with the contexts in a project. But the provider and consumer would just lose connection if they were imported from different versions of context package, because from React perspective, it's just two different contexts. So we moved this kind of packages to pure dependencies of other packages, and we made sure that they were placed in direct dependencies section only in projects. And this is the thing that we, for now, control manually, because it's complicated to stop some automated systems that controls how dependencies used across many packages inside the company. The second problem was that our CSS classes were clashing. Since CSS is globally scoped by default, there were conflicts between newer and older versions of styles. Our solution for this problem is CSS isolation. Basically, CSS isolation transforms your human-readable class to something like this. In our case, some minor style changes on projects were applied directly using CSS classes. It's a hack from a design system perspective, but sometimes developers need to apply hacks. So we left the original class name inside the isolated one, and now developers can do something like this. But it's a bad practice. Please don't use it. At least it's easy to find inside the project code, but try to avoid it as much as you can. Okay, we can for CSS isolation we considered two options: CSS in JS and CSS-modules. CSS in JS looks nice, but it has some drawbacks for us. To use CSS in JS at full power, you need a runtime. And we have many versions of many packages on projects. So with that, we could end up with many versions of CSS and JS runtimes on one project. And the second one is that there is no standard universal way to make CSS and JS library or framework work with server-side rendering and server-side generation. And we have these technologies at some of our projects. And remember, in previous iteration, we decided to set the lowest infrastructure requirements for client project possible. So we went with CSS-modules. However, we didn't have a bundler. Thus, it's critical for CSS-modules to have information from CSS build inside the JS build, which usually contained in a bundler. So we wrote our custom Babel plugin that runs CSS build inside JS build to have information from CSS build during JS build. But at the time, we still had some CSS API usages of components that should be supported. So the final build pipeline looks like this, which is pretty redundant and complicated to support. As I mentioned before, some minor style changes like change in primary color were applied by using CSS classes. Now it was only achievable with the hack. So we needed an official way to customize components. CSS variables were the perfect choice, but back then we still supported Internet Explorer. And CSS variables can't be completely polyfilled with Cascade inside Internet Explorer or other browsers, which doesn't support CSS variables. Because CSS variables are considering DOM structure, and Cascade is considering rules order. So our CSS variables-based styling API had to have at least a fallback for Internet Explorer. We used the PostCSS custom properties plugin to add such fallbacks. It adds a fallback value from the root rule to CSS rule, which rules which are using CSS variables like this. So in browsers that don't support CSS variables, the second line is ignored. While in those that support, second line is overrides the first line. After adding the plugin and moving the primary color to CSS variables, we saw this in our projects at Developer Tools. Basically, it's the same problem. CSS variables from all packages end up in the global scope, and we can just isolate CSS variables by adding hash to their names, because they are public API and their names should remain stable. In order to fix this, we patched PostCSS custom properties plugin, And now instead of this transformation, which requires CSS variable default value to present in a root scope, it removed default value from the root scope and put it into variable usage. So in this case, variable can be customized by values from the global scope, but doesn't require having default value in the global scope. That is how we got to enhancing the second version stack with CSS-modules and isolated React components. And this stack serves us pretty long time, but it have some fundamental issue. Complicated styles build, which I mentioned earlier, and always outdated typings. By the time, some projects that were using design system were migrated or start using TypeScript, but components were written in JavaScript. So we just put DTS typing files into the packages, but they contain a lot of bugs. Teams that use TypeScript came up with some creative workarounds, which is also bad practice. Please don't write code like this or avoid it as much as possible. They applied such workaround because they didn't want to slow down while waiting for the fixes from the design system side. Also, design guidelines and components documentation were hosted in different places, which was not obvious for newcomers and caused many broken links between these two parts of documentation. The requirements for the third version directly correspond to those issues. We wanted to simplify the build by leveraging a bundler, rewrite components in TypeScript, create new user-friendly design system documentation, and somehow improve CSS API, because at that time, many of the projects were written in React, and we could drop plain HTML pages support because pure CSS API can't be isolated by design, because class names is the actual public API and should be stable. And CSS isolations add some hashes to CSS classes. So we got rid of custom CSS modules Babel plugin by adding rollup. We finally got a build tool with information from the CSS build that can be used inside JS build. And integrating TypeScript with a monorepository turned out to be tricky, because TypeScript has its own concept of projects. And the build of a particular file depends on the project scope. In our case, we have this kind of file structure. So when you build documentation or navigate through code using an IDE, all the components should be considered as one project. But when you build a particular component to publish, it should be considered as separate project. So, as we wrote a custom script that adds a tsconfig file to every package before build and publication, and remove it as a part of build and publication process. For documentation, Style Guidist was a nice solution, but it had some limitations that made it difficult to integrate our design team's guides into it. So we wrote our own documentation engine based on Next.js and MDX with same cool sandboxes that Style Guidist has. And there is a separate talk about it from Andrei Grindelevsky, which he gave at last year's JS Day. Okay, so we removed CSS API, but we still had some components that were purely stylistic. For such components, we want a solution that was as simple and obvious as classes, but still isolated with CSS modules. After some experiments, we came up with an idea that we called chain helpers. Chain helpers is a pure function with parameters returning a string of CSS classes processed by CSS modules. It works like this. I added some formatting to make it look better on slide. These functions are written in TypeScript, so you can get contextual documentation, which improves developer experience. You can just see what parameters this component or helper have and which values can be applied to these parameters. These functions can be easily mixed with some custom classes if you need to add your custom CSS to it. So in the third version, we rewrote the components, the documentation engine, and the build system. And we introduced a new way to distribute isolated styles. And that is how our current stack was chosen. It may seem like we've been fixing minor things here and there all along. But I think that a design system is where you need to care about the little things so that project developers don't think about them and don't spend time figuring out how to configure the build infrastructure or how some complicated API works. Around 10 teams within the company use our library of components and our guides. And I want to thank them for their feedback, which helped us a lot. We tried to make the stack of our design system as simple as possible. It's still not perfect, but every part of it has some reason and purpose. And it helps us to reduce time to market and as a burden on developers. I hope that some of our ideas will be helpful for you. Thank you. This is the way.